All right. 1 second. Okay, so the quick review, how would I go about finding the inverse of something that says y equals x squared? So what's this first step in finding the inverse? Do you remember? If not, it says step 1 right below it. Yeah, switch the x and y. So x equals y squared. Now if I wanted to get y by itself in order to solve that inverse, what would you do? Good. And my final answer would be y equals what? Half credit. Thank you. Good. So that would be the inverse of y equals x squared with the plus or minus, right? If I wanted to find the inverse of y equals 2 to the x, first step is the same. X equals 2 to the y. So you really have to pay attention to what you're trying to cancel here. You're not trying to cancel the exponent this time. You're trying to cancel the base. And based on what we just talked about over there, if I want to cancel something with a base 2, what would I need to apply to both sides in order to do that? The log base 2. Now the log base 2 is a function. Sorry, it's hard to write because it's so scrimped. The log base 2 is a function, kind of like the sine function is a function. I'm not going to multiply both sides by log base 2. That encompasses it. So the log base 2 and the 2 would cancel. The power comes down, so your answer would be log base 2 of x equals y. So this function and this function are inverses of each other, which is helpful when it comes to graphing the log functions, which we will do in just a second. So step 1, switch the x and the y. Step 2, pay attention to what you're trying to cancel. We're trying to cancel the base, not the exponent. Logarithms cancel the base. So again, to cancel a base 2, you use a log base 2. To cancel a base 3, log base 3, and so on. Step 3, you'll cancel the base by applying the log base 2 to both sides, and you simplify. So looking at these, there's 2 different ways I could write something. Let me go back up here. This right here is called exponential form. This right here is called logarithmic form, and you can go from one to the other. What this means, if I wrote something like this, hold on, let me think about it. Sorry. If I wrote something like this, log base 2 of 8, what it's saying is 2 to the what power equals 8. So 2 to the third power would be 8. So that's kind of the setup of the log. If I add log base 5 is 25, what would that equal? 5 to the what power is 25, right? 5 squared is 25, right? So this would be a 2. See that one? Log base 3 of 27 equals what? This 3 cubed would be 27. One more to make sure you're with me. Log base, I don't know, you get to big numbers fast and then it's hard now. Log base 6 of 216. Oh. You get this? You're going to see a lot of numbers that are pretty small, then they grow so fast, right? So that's what a logarithm means. Now you can write this as a logarithm. Sorry, I'm stay over here for a second. Sorry, you're recording, you can't see any of this. So you can rewrite this as a log, but you can also write this as an exponent. These two right here would be equivalent statements. 2 to the third power equals 8 log base to the base 3. So if I give you something, in exponential form, you can rewrite it in logarithmic form. And if I give you something in logarithmic form, you can write it in exponential. So let's move on. Example 1, we're going to start by writing the exponential equations in logarithmic form, which means I no longer can have the exponent, I only can have log. So looking at this right here, I have to cancel out the base 10. What kind of log would cancel out a base 10? Log base 10. So if you want this 2 to no longer be in the power and to be down below, you have to apply the log base 10 to both sides. And on the left, we have log base 10 of 100 equals 2. Does that work? Is 10 squared 100? Yeah. Let's do it again, part B. If I want to cancel that 3 down, what do I have to apply to both sides? Good. So log base 3. Log base 3. On the left, we have log base 3 of 81 equals what? 4. Is it true that 3 to the 4th power is 81? Yes. It's probably wise to go back and check yourself to see if this makes sense, because if you had log or 3 to the negative 4 equals 81, that number seems a little bit off, right? So it's just a good way to go back and see if you're doing it right. What about part C though? I want to get rid of the 3. What do I do? 3, 3, those cancel, and you have negative 2 equals log base 3 to the 1/9. Does that work? Is 3 raised to the negative 2 equals 1/9? Because what does the negative do when it's a power like that? Right. If I go this direction, that's the same thing as 1 over 3 squared, right? And the negative flips it underneath the fraction line. And 3 squared and 1/9, same thing. Okay, on your own, try part D. Write it in logarithmic form. There's going to be questions like this on the test. I already told you, right, that this is a calculator, non-calculated test. You'll get parts of both of them. If you're testing while I'm not here, maybe I'll make that test a little bit easier. Okay? And then I'll show you how to plug in like log base. I'll show you how you can plug it. Okay, so I'm trying to get rid of the base 10. What do we do? Log base 10. Log base 10. Those cancel, so negative 2 equals log base 10 of 0.01. So 10 to the negative 2, it's kind of the same problem with the 0.01. All right, in just a minute, we are going to go backwards from logarithmic form to exponent form. But first, yes?
What is your exponent in the 0?
What? Okay, so what's x to the 0? Where are you? Where? Okay. Okay, moving on. So you can use this exponential form idea to help evaluate logarithms. So that's what we're going to do here. Some problems are a little bit easier than others. I'm going to change things around a little bit just to help with your homework assignment tonight. Change this one to a base 2. Log base 2. And then change this one to 1/16. This is probably the hardest part of today. Alright, so if we could, hold on, backtrack. The log base 2 is going to cancel what kinds of base? A 2, right? If I could rewrite this 32, so it was 2 to the something power, then this log base 2 and that 2 would cancel, and we would just be left with the exponent. So 32 is a 2 to the what? If you need to, you can go to the side. What times what is 32? 8 and 4, and then what is 8? 4, 2, and so 32 is a perfect 2, right? 2 to the what powered? So I could rewrite this 32 as a 2 to the 5th power. Are there any questions with that? Now, between the log base 2 and the 2, they cancel, and all that would be remaining is 5. These are cool puzzles. I really enjoy them.
How did you get the 2?
Which 2? Which two?
The logic thing you crossed out by mistake.
Oh, I would backtrack a little. Hold on. That two?
Yeah.
Okay. I got that two because I knew this right change problem. I knew that if I wanted this two to cancel this two, they'd have to be the same number.
Okay.
And I recognized that 32 was a perfect two. So I wrote two, and then I just needed to find out that this was a fifth power
Okay.
so that they would cancel. Okay. So likewise, on this one, 125 is what times what times what? 5 to the third, right? So I could rewrite this. I'm choosing 5 strategically so that they'll cancel, right? So 5 to the third. And then what happens between the log base 5 and the 5? They cancel, and what are we left with? A 3. Any questions with that? So flip over, open your homework really quick. Can you please try problems 1 through 4, and then try 6 and 7. So not a lot. 1, 2, 3, 4, 6, 7. Take 4 minutes or less. Preferably less. I hate recording lessons. Except for it. I don't know the walk around. Everyone's not me. Let me give you a couple more examples of that. Alright, I'll do it. If I had log base 5 of 1 over 25, how would you rewrite this so it had 5 as the base? 5 to the what is 1 over 25? Maria? -2? The negative makes it so it's a fraction. The 2 makes it so it's the 25. So if you have log base 5 of 25, those cancel. What's my answer? -2? Do another one. Log base, 3 of 1 over 81. So this is the same thing as saying 3 to the what? Negative, what times what times what times what equals 81, huh? The 3 to the 4th, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. So what's going to happen between those two? Log base 3 and 3 cancel. What's my answer? -4? Okay, let's do another one all on your own this time. Log base 10 of 1 over 100. What would the power have to be in order to get you 1 over 100? Is it true that 10 to the -2 is 1 over 100? So log base 10 of 10 cancels, you get what? -2. Give me a 5, 4, 3, 2, 1. How well do you understand that? Okay, let me do one more. Try that one. So anytime if you're making a rule, anytime you see a log base anything of 1 over something, if it's a 1 over, you know that the answer is going to be what? Negative, because the negative is what's making it into that fraction. And then you just have to look at the 625. What times what time is, or how many 5s do I need to get the 625? 4? Because 5 times 5 is 25, 125, 625. So this right here is the same thing as saying this, 5 to the -4th. Those cancel, we are left with -4. What about this one? What would you have to raise the 5 to, or the 25 to, in order to get 5? So this is kind of backwards. So this has to be a 25 base. What would the power have to be in order to maintain the value of 5? But then the log base 25 will cancel. 25 to the what? 1/2? Because is it true that the square root of 25 is 5? So if we wrote it as 25 to the 1/2, these will cancel and we're left with what? 1/2. you have it done so already, we need to finish problems 1 through 8 on your homework. We are temporarily skipping question 9. Because I don't have time for it today, and I don't think the grand students will be able to come by today. So if it were to make your schedule, 3 questions. The 25 can make it 2, would be 1 over 25 squared, not 5. It's not the value of 5. So the 1/2, if I put x to 1/2 is the same thing as the square root of x. I rewrote something with a base 25, and I wanted my answer to be 5, maybe I have to take the square root of it. So that's what it's doing. So then we'll be at square root of it, not at the There's also one other thing I'd like you to do. On that graph below on question 10, I like the y equals log base 2 of x. Can you change the other one to y equals 2 to the x? So instead of a 1/2, change it to a 2. That will mean that the graph and those 2 graphs are inverses. Which means on my answer to you it might be 1. I don't know. Maybe I changed it. Today? One second. Yes. No, I didn't. That's okay though. So on number 10, one graph that you're trying to graph is log base 2 of x. The other one is 2 to the x instead of 1/2 to the x. I want to change it to a 2. Okay, let's move on. Now the common logarithm, just a minute ago, Lee and I were talking about how you plug this into the calculator, and he said it always is defaulting to a base 10. That's because base 10 is kind of the default log. So it's called the common logarithm. We just call it log base 10 or just log of x. So you can write a common logarithm rather than writing base 10, you can just write it as log of x. That doesn't answer how you plug it into your calculator in different ways. We will do that. I don't know if we do it today. So if not, I can show you. That's really what I have. Example 3 goes with number 9 on the homework. It's a good problem. However, I don't think we'll have time for today, so let's skip it temporarily and move on to example 4. Okay, so graph both y equals 10 to the x and its inverse, log of x, on the same graph. This one right here we learned to graph on day 1 and on day 2. The other one we haven't yet. We just know that it's the inverse of this one. So looking at the y equals 10 to the x, what's the starting value? 10 is the multiplier. So 0, 1. Yeah, there's a little imaginary 1 times right here. So my starting value is 1. And then to get to the next point over, we multiply it by 10. So then right here, it's a really steep, probably terrible graph. Something like that. So this one is 10 to the x. How do you suppose we would use that to graph the log function? Because it's not easy to plug values into the log function. I mean, you can. But how would we use the 10 to the x to graph the log? What do you think? Oh, good. Yeah. Good. Erin, keep saying what you were saying. It's not the same thing what you said, but keep talking. Good. So this is my 10 to the x function, right? So what values did I plug in here? I plugged in 0, got 1, and then what else? 1 and 10. So if I'm doing the inverse function, isn't that switching those? So rather than 0, 1, I have 1, 10, and then 0, 1 here. Now, if I only have 2 points, you could put anything through it. You just have to know kind of, in this case, the shape. I need to know that it's curved like this and it's not a straight line. So at 1, 0, and then it's 10, 1. This right here is considered the parent graph. It's a logarithm, base 2. Base 10. Sorry, what? Yeah, remember initially how we drew it when we were doing inverses, when we drew the line right here, and we said it looked like it's going to flip over that line? Yeah, it's the same sort of idea. Good. So now we're going to do a couple transformations on the log function. Let's look at log base. Let's change this to a base 3, if that's okay. There's a base 2 now, right? So let's do base 3. In order to graph the log base 3, you should know which other graph. So what would the inverse be of log base 3? 3 to the x. Good. So if I'm graphing that one, my starting value is 1. To get to my next point, multiply that by 3. To get to my next point, 9. And it will look something like this. Except for I don't care about those points, right? I care about the inverse of those points. So if this is my xy, we said 0, 1, 1, 3, and 3, 9. What would the inverse be? 1, 3, 9, 0, 1, 3. So yeah, those points are there. Ignore them. 1, 0, 3, 1, and 9. It's saying 3 cubed is 9. 3 to the first power is 3. 3 to the 0 power is 1. And that looks something like this. So there's the parent graph. Questions with the parent graph? Sorry, I'm standing in the way. I changed the parent graph. I changed what we were doing to a 3. Sorry. So this changed this one to a 3. We're looking at this here. Did I screw up? Oh, you're saying this right here, this right here, this right here. Point, not right here, it's different point. So that's what we're doing. Got it, sorry, thank you. Yes. Okay, now, how does this one, pretend like that's a 3, compare to that one? What does the 0.5 do? Good. Now think of it as the transformation. If it was 0.5x squared, or 0.5x cubed, or 0.5 square root x, what would the 0.5 do? So I'm going to take all of my up, which is the y values, and do what with it? Let's do that. Let's take all of the up and multiply it by 0.5. And when it does that, this is why your starting point is this first number. When it does that, at 0, what would y be? 0. Or at 1, still 0, because half of 0 is still 0. At 3, how far am I up? 0.5. So 1 times 0.5 is 0.5. At 9, I'm at half of 2, which would be 1. So it should look like that one, but flattened, does it? So how does it compare to the parent graph? It is half as high. Compressed. Questions on that page? I take all of my ups and I half it. Okay, next piece. Again, we're still looking at the cube function. What do you suppose will happen with this one? X minus 4. And we do all of my points and do all of them. Move those forward. So really quick, will somebody tell me what the xy graph is for the log? So it was, hold on. So 1, 0, okay. It was like that? No, it was the other way around, right? This was for the exponent? Okay, so for the log, it would be reversed. So 0, 1. Is that right? No, 1, 0. 1, 0, then what? 3, 1, and then 9, 2. So that's the parent function. What do you think this minus 4 will do? It's going to shift everything to the right or to the left? To the right. So I'm going to add 4 to all of these. I'm shifting it to the right. I'm going to add 4. So your new vertical asymptote, you can see, is going to be right here. Not going to pass that line because we moved it right forward. And if we graph those points, instead of 1, 0, it's going to be 5, 0. And then the next point would be where? 7, 1. And then the next point? 13, 2. Get this off the grid so the graph would look something like that. Not quite so flat, but something like that. So what's happened there? The graph is moved right forward. Look at the next graph. I'll put in the parent graph here, 1, 0, 3, 1, 9, 2. This graph has done what? This one, right 2, this one, up 3, right? So each of these points need to move. Right 2, how do I change these ones? I do what? Add 2. And then how do I change these ones? We add the 3, good. You can do this on a table like I'm doing it right here, or you can graph the parent and just shift the points like I did yesterday. Either one of those is fine. Devin, you okay? So, points are 3 what? 3, 3. And then 5, 4. And then 11, 5. Horizontal asymptote should be here at 2. Something else. Okay. Really quick, let's talk about the E. E is a natural number. You can get E by doing a really long. It's like 1 plus 1 over n to the n or something. As n gets really, really big, what value would this be? That's how you find E. Kind of ugly. If the base is E.
Yeah, Maria's here. Superintendent for checkout, please.
Yeah. If E is the base, what kind of log would you need to cancel that? Yeah, the log of E. And like I said before, ln is the natural log. So it's backwards instead of NL, like the N stands for natural, L is log. It's Italian, not Italian, Latin. What in Spanish, what happens when you're trying to describe something to the describer? It comes before the word or after. Like we say the green frog, but in Spanish you would say green, frog green, right? Kind of the same thing. They flip the L and the N because of the language. So natural log, flip. But the LN and the E are inverses of each other. So if I'm trying to cancel one out over the other, this is what I'll use. So for example, let's rewrite these in exponential form. Sorry, I'm pushing through because we only have 20 minutes and I don't know how much time you'll have. So if I want to write this in exponential form, that means I need an exponent. What exponent is going to cancel out the natural log? E. Now I don't know how to say this using like correct mathematical language. So we are going to E both sides. We're going to E both sides. The ln and the E cancel on the left, so you have 4 equals E to the x. On the next one, if I want to get rid of the natural log and write it as an exponent, what's going to cancel the natural log? E. So what do? You E it. Yeah. So on this one you have 9 equals E to the 2x. Being able to go from one form to the other will be useful because soon we will be solving equations where you have to cancel out either an exponent or you have to cancel out a log. So you need to be able to go from one to the other. So let's do it in reverse now. Now we're going to rewrite them in logarithmic form. Make sure you read the instructions. These are some of my most missed questions on the test because once you do it this way, it's super easy, so you don't really think about it. And then you're going to start solving equations, and you're no longer going to remember how to do this. It's just the first step. How do I go from exponential to logarithm? What's going to cancel out the E? The ln. Mine are really squirrely and they look like a bunch of scribbles. So the natural log of 7 equals x. That's it. I'm going from one one to the other. This is like the first step in solving an equation. So on part B, what would you do? You apply the natural log to both sides. The natural log and the e cancel. You get 4x equals the natural log of 16. And then I could solve for x if I wanted to. It doesn't ask us to, but don't. If I wanted to solve for x, what would I do next? Divide 4. Good. Questions on that? It's kind of the same thing, but we're using natural log rather than the log. All right, moving on. So we're going to cancel these kind of in a similar way that we cancel the other ones. Do we have more notes? No. We're going to cancel these in a similar way. On part A, what simplifies here? The natural log of e, what happens? We cancel, so you're left with a what? 4. What about on part C? The 3 and the log base 3 do what? They cancel, so what are you left with? Fantastic. What about part B? What do you have to do to simplify that one? You're at the E or the 8, right? That's what? 2 to the what? Third. And so then the log base 2 and the 2 will cancel. You're left with 3. And then part D. What's the base on part D?
1.
Oh, no.
2.
Still no. Read the top of the last page. 10, right? The common logarithm is base 10. So if it doesn't have anything here, it's base 10. How would you rewrite this number as a base 10? However many zeros there are, that's what the exponent is. Did you know that? What do you do now? Okay, so what's going to happen here? Log base 10 and 10 cancel. You are left with 4. So let's go back to problem 16 on your homework from day 2 really quick before we're done. Because we can use this idea right here to solve the equation. Head over to my... Now it's a situation, it doesn't give you an equation. This is 8.2, number 16. What does it say? Okay, hold on. So, do we know how much the principal is? No, but the amount after however long is going to be twice that, right? Okay, what's the interest rate? 6.5%. And what are we looking for here? We're looking for the time, right? So that's our final goal. Now, it doesn't matter if you deposit $1 and you're waiting for it to grow to $2, or if you deposit $1,000 and you're waiting for it to grow to $2,000. The amount of time that it takes is exactly the same. Okay? Because it's a ratio. So, if you only deposit $1, you're going to wait just as long for that to double as you would if you deposited $1,000 and waiting for that to double. So it doesn't matter what you put in here. You can say, I'm depositing $1, and when will I get $2? It will be the same time, because when we set up your equation, this is a say compound continuous, which is that matters. Okay, so we're using the equation A of t, you know it? T, E, RT. Let me show you really quick. If I deposited 1,000, don't write this down, and if I wanted to get it to 2,000, who cares about that? The very first thing you'll do is divide by 1,000. Is that okay?
Yes.
So divide by 1,000, and what do we get on this side? 2. Let me show you the other scenario. Pretend like I deposited $1, and I wanted it to grow to $2. How would I get t by itself? Isn't it the exact same equation? So the amount of time it takes for something to double is exactly the same, regardless of how much you input. Is that okay? All right, so moving on. Now the rate is what? 2 equals e to the, what's the rate? So how do I write that? 0.65 t. So you have to solve for t here. Using what we just barely learned, how would you cancel the e? You would natural log both sides. So the natural log of q is something ugly, the natural log of e goes away. On your calculator, what is the natural log of 2? Give me 4 decimal places. So the natural log is 0.6931. You see the LN button on your calculator? It should be really close to the log button. And then the natural log 2. 0.09 or 0.6931 equals, on the right hand side, those canceled, 0.065 t. Now how do I solve for t? Divide by 0.065. So it's going to take you, if you deposit no more, 10.67 years for your money to double at an interest rate of 0.65. Does that make sense? There are some other problems on your homework. Thanks for watching. Peace out. There are other problems on your